Friends, myself Manjudeep, studying in Sri Venkateswara College of Engineering, Bangalore. Today I'm going to discuss on the topic Introduction to Mathematical Induction, which is a topic from Discrete Mathematics of fourth semester CSE. So mathematical induction is a powerful technique for proving statements about natural numbers. It involves demonstrating that a statement holds true for the base case and then shows that if the statement holds for a particular value, it is also holds for the next value. The principle of mathematical induction. So fundamental idea. So the principle of mathematical induction is a powerful logical method used to prove statements or proportions that are true for all natural numbers. Step-by-step approach. To prove a statement using induction, you must establish a base case and then show that if the statement is true for a certain numbers, it is also true for the next numbers. And broad applicability. This principle can be used to prove a wide range of mathematical statements from simple arithmetic identities to complex theorems in computer science, algebra, and combinations. So base case. So the base case is a starting point of a mathematical induction proof. It establishes the truth of the statement for the simplest or the smallest possible value of the variable. So typically the base case involves verifying the statement for n is equal to 0 or n is equal to 1, as these are the most fundamental starting points. So proving the base case is the fundamental foundation upon which the entire induction argument is built. It ensures that the statement holds true for the initial condition before proceeding to the demonstrating the inductive steps. So inductive step. So first one is hypothesis. Assume the statement is true for a particular value of variable, such as n is equal to k. Second one is inductive argument. Use logical reasoning to demonstrate that if the statement is true for n is equal to k, then it must be true for the next value that n is equal to k plus 1. And the next one is proving the calm. So combine the base case and inductive step to conclude that the statement is true for all values of the variable. So proving statement using induction. So mathematical induction is a powerful technique to prove statements about natural numbers. So the process involves establishing a base case and then showing that if a statement holds for any arbitrary numbers, it is also holds for the next number. So by repeatedly applying these induction steps, you can systematically prove that the statement holds for all natural numbers. This method is particularly useful for demonstrating patterns and relationships in mathematical expression and algorithms. So induction on natural numbers. So numbers. The principle of mathematical induction is particularly useful when proving statements involves natural numbers. So the non-negative integers 0, 1, 2, 3, and so on. So by establishing a base case and then showing that the statement holds for all larger natural numbers, we can conclusively prove that the statement is true for all natural numbers. So 1, 1, 5, and 5 natural numbers, and 10 and 10. The induction of natural numbers follows a clear logical progression. So we first verify the statement is true for the base case 1 or 0, then show that if it is true for some arbitrary natural numbers n, it must also be true for the next number n plus 1. So this process can be repeated identical indefinitely to prove the statement holds for all natural numbers. So induction on integers. So extending the principle. So the principle of mathematical induction can be extended to prove statements about integers, both positive and negative. This allows us to establish patterns and relationships that it holds true for the entire set of integers. Then proving divisibility. The induction on integers is often used to prove divisibility properties, such as showing that the sum of consecutive odd integers is a perfect square, establishing inequalities. So induction can be applied to demonstrate various inequalities involving integers, like showing that the sum of the first n positive integers is always less than n square. So recursive definition. So induction on integers is crucial for understanding and proving properties of recursive definitions, which are commonly used in computer science and mathematics. So induction of a sequence. So define the pattern. So identify the undefined rule or relationship in the sequence. Base case. Verify the statement hold true or the first term of the sequence. Inductive step. Prove that if the statement is true for any arbitrary term, it is also true for the next term. Mathematical induction can be used to prove statements above sequence where we need to demonstrate that a given property holds true for all terms in the sequence. This involves establishing a base case and then showing that if the property holds for one term, it will also hold for the next term, thereby proving the statement for the entire sequence. Application of mathematical induction. So for proving formulas, mathematical induction is commonly used for proving mathematical formulas and identities such as the sum of first and natural numbers or formula for the n Fibonacci number. Analyzing algorithms. So induction is essential for analyzing the correctness and time complexity of an algorithm, helping computer scientists design more efficient program. So verifying hardware. So engineers use inductive recursion to verify the correctness of digital circuits and computer hardware, ensure reliable and secure electronic systems. So rigorous proofs. So induction is a fundamental proof technique that allows mathematicians to establish a general truths with a high degree of rigor and confidence. Conclusion and keys. Takeaway. Summary of key concepts. So mathematical induction is a powerful proof technique for establishing the validity of statement involving natural numbers. So it consists of verifying a base case and then showing that if the statement holds for some number, it also holds for the next number. And the second one is wide application. So principle of mathematical induction can be extended beyond natural numbers and have applications in computer science, mathematics, and many other fields for proving the correctness of algorithm, identities, and more. Third one is important in computer science. So induction is particularly crucial in computer science, where it is useful to verify the correctness of recursive algorithm, data structure, and other fundamental concepts. And the fourth one is continued learning. So mastering mathematical induction take practice. Continuous exploring of examples and applications will deepen your understanding and unlock its full potential in your studies and problem solving. So thank you so much for watching my video.